The load profile section typically provides information about various aspects of the database workload. Various metrics provided are per second, per transaction, per execute. Per second, it shows the average number of transactions, parses, and other important activities that occurred per second during the analyzed period. Per transaction, it shows average number of physical and logical reads, database block changes, and rows processed per transaction. Per execute, this part displays the average CPU time and elapsed time per SQL or PL/SQL execution. DB time, the total database time, in seconds, per second, which indicates the time spent by all user processes in the database. It reflects the overall workload on the database. DB CPU, the amount of CPU time, in seconds, used by the database processes per second. This metric indicates the CPU utilization by the database. Redo size, the size, in bytes, of redo logs generated per second. It shows the rate at which changes are made to the database. Logical reads, the number of data blocks read from the buffer cache and consistent read, CR, blocks per second. It reflects the data access pattern and I/O activity. Block changes, the number of data blocks changed, updated, per second. It indicates the amount of data being modified. Physical reads, the number of data blocks read from disk per second. It shows the I/O activity from storage. Physical write, the number of data blocks write to disk per second. It shows the I/O activity from storage. Read I/O requests, the number of read input-output I/O requests issued by the database. Write I/O requests, the number of input-output I/O requests made by the database to write data to the storage media, disk. IM rows, the number of rows retrieved via in-memory scan operations. User calls, the number of calls to user functions or procedures per transaction. Parses, the number of SQL statements parsed per transaction. This part shows the average number of hard and soft parses per second. A high number of parses can indicate inefficient application coding or shared pool sizing issues. Hard parses occur when a SQL statement is compiled and executed for the first time or when there is no shared SQL area available for reuse. It shows the number of SQL statements hard parsed per transaction. Hard parses occur when a SQL statement is not found in the shared pool and needs to be completely parsed before execution. Soft parses occur when a SQL statement is executed, and it can reuse an existing shared SQL area without needing to be fully recompiled. Logons, the number of logons per transaction, representing the frequency of user logins. Recursive calls refer to internal database calls generated by SQL statements issued by user sessions. It shows the average number of recursive calls per second and per transaction. Executes, number of SQL statements which were executed. Transactions, indicates how many transactions occurred. Rollbacks, the number of rollbacks occurred. The AWR report provides information about transactions and rollbacks, i.e. the number of commits can be calculated as the difference between the two. Rollbacks are expensive operations. Dependent on the weights, the load profile section either provides useful general background information or specific details related to potential issues. In the example, the weights section shows potential for issues with the execution of SQL, so the load profile can be checked for details in this area, although it is not the primary source of such information. If you were looking at the AWR report for general tuning, you might pick up that the load section shows relatively high redo activity with high physical writes. There are more writes than reads on this load with 42% block changes. Furthermore, there is less hard parsing compared to soft parses. If there was a mutex weight as top weight such as library cache, mutex X, then statistics such as the overall parse rate would be more relevant. The instance efficiency section shows information for many of the common hit ratios. Hit ratios are a great alert mechanism for general potential problems or specific potential problems, such as bad SQL, that has been introduced recently into the system. You need to keep in mind the characteristics of your application, whether it is query intensive or update intensive, whether it involves lots of sorting, and so on when evaluating the instance efficiency percentages. Buffer now 8 ratio. This is the percentage of time that the instance made a call to get a buffer and the buffer was made available immediately, meaning it didn't have to wait for the buffer, hence, buffer now 8. If the ratio is low, then could be a hot blocks being contended for that should be found in the buffer wait. Buffer hit ratio. Also known as the buffer cache hit ratio, it shows the percent of times a particular block was found in buffer cache instead of incurring the overhead of a physical I/O, reading from disk. When these buffers are read, they are placed at the most recently used, MRU, end of the buffer cache. Iterative access to these buffers can artificially inflate the buffer hit ratio. This information in those cases could be misleading. Library hit ratio. This ratio, also known as the library cache hit ratio, gives the percentage of pin requests that result in pin hits. A pin hit occurs when the SQL or PL/SQL code to be executed is already in the library cache and is valid to execute. Shows percent of times SQL and PL/SQL found in shared pool. If the library hit ratio is low, it could be indication of small shared pool. Execute to parse. It is a measure of the number of times a SQL is executed versus the number of times it is parsed. If this value is negative, it means that the number of parses is larger than the number of executions. Parse CPU to parse elapsed percent, it is a measure of how available CPU cycles are for SQL parsing. This percentage we'd like to see near 100. If it's not, then it meant that something stopped us from getting access to the CPU, i.e., it's an indicator of possible contention. Redo now 8 ratio. This ratio indicates the amount of redo entries generated for which there was space available in the redo log. The instance didn't have to wait to use the redo log. In-memory sort ratio. This ratio gives the percentage of sorts that were performed in memory, rather than requiring a disk sort segment to complete the sort. It shows how efficient sort_array_size, hash_array_size, or PGA_aggregate_target are. If you don't have adequate sizes of sort, hash, and PGA parameters, then your in-memory sort percent will go down. Soft parse ratio. This ratio gives the percentage of parses that were soft, as opposed to hard. Latch hit ratio. This is the ratio of the total number of latch misses to the number of latch gets for all latches. Latch hit percent of less than 99% is usually a big problem. Also check the shared pool statistics. If the end value is in the high 95% to 100% range, this is an indication that the shared pool needs to be increased, especially if the begin value is much smaller. Percent non-parse CPU. Most of our statements were already parsed, so we weren't doing a lot of reparsing. Reparsing is high on CPU and should be avoided. Example. Efficiency percentages. Buffer now 8%, 99.98 indicates that almost all buffer requests did not have to wait for a free buffer, showing excellent buffer utilization. Buffer hit percent, 99.92 signifies that the database efficiently finds data blocks in the buffer cache, reducing the need for disk I/O. Library hit percent, 97.00 shows that 97% of SQL and PL/SQL statements were found in the shared pool, indicating a good library cache hit rate. Soft parse percent, 98.95 suggests that most SQL statements were efficiently soft parsed, reducing the parsing overhead. Latch hit percent, 100.00 indicates that all latch requests were fulfilled from the in-memory latch area without any contention. Shared pool statistics. Memory usage percent, 91.53 means that 91.53% of the shared pool memory was used, which is within a reasonable range. Percent SQL with executions 1, 93.02 tells us that 93.02% of the SQL statements were executed more than once, indicating a substantial workload with repeated queries. Percent memory for SQL with exec 1, 92.53 means that 92.53% of the shared pool memory was used to store SQL statements with executions greater than 1. Percent non-parse CPU indicates that almost all the CPU time that we see in the top weights section is attributable to execution and not parse, which means that tuning SQL may help to improve this. If we were tuning, then 94.48% soft parse rate would show a small proportion of hard parsing, which is desirable. The high execute to parse percent indicates good usage of cursors. Generally, we want the statistics here close to 100%, but remember that a few percent may not be relevant dependent on the application. For example, in a data warehouse environment, part parsing may be higher due to usage of materialized views and/or histograms. So again, comparing to baseline report when performance was good is important. Foreground events by total wait time section provides insights into the most significant events causing wait time in the database. Event. This column lists the specific event or wait event that caused the most significant wait time in the database. Examples: DB file sequential read, log file sync, CPU time, etc. PCT-DB time. This column shows the percentage of database time spent on the specific event. The higher the percentage, the more significant the impact. Wait time. This column displays the total wait time in seconds for the event during the snapshot. It represents the cumulative time that sessions spent waiting for this event. Average time. This column shows the average wait time in seconds per occurrence of the event. It helps assess the duration of individual waits for the event. Waits. This column displays the total number of waits for the event during the AWR snapshot period. It indicates how frequently the event occurs. Percent timeouts. This column represents the percentage of timeouts that occurred for the event. Timeouts occur when a session gives up waiting for the event after a specified period. Total waits. This column shows the total number of times that sessions had to wait for the event, including both successful and timeout waits. Average wait. This column represents the average wait time in milliseconds per wait occurrence for the event. Wait class. This column categorizes the event into a specific wait class. Wait classes group related events together, providing a higher-level understanding of the types of waits that occur in the database. Examples of wait classes include user I/O, commit, concurrency, etc. %DB time. This column displays the percentage of database time spent on the event within its respective wait class. Wait classes by total wait time section provides valuable information about the different categories of wait events and their corresponding total wait times. By analyzing the wait classes by total wait time section, you can identify the areas of the system that contribute most to the overall wait time. For example, if the user I/O wait class has a high total wait time and percentage of DB time, it suggests that the system may be experiencing performance issues related to disk I/O operations. Wait class. The first column in this section lists the various wait classes. A wait class is a high-level category that groups similar types of wait events together. Oracle provides predefined wait classes such as user I/O, concurrency, commit, system I/O, network application, configuration, and idle. Total wait time. The total wait time represents the cumulative time spent by the database in various wait events within a specific wait class. The unit of measurement for the total wait time is usually centiseconds or hundredths of a second. %DB time. The database time spent metric helps identify the wait classes that consume the most significant proportion of the database's processing time. Wait time. The wait time per second for each wait class represents the average time the database spent waiting for events in a particular class during each second of the snapshot interval. Waits. The fifth column represents the number of wait events that occurred within each wait class during the AWR snapshot interval. Average time. The average time indicates the average duration of individual wait events within a specific class.